Hi Jane, could you hear me?
Yeah.
Yeah. Okay. So today we're going to go through the chemistry. That is the
Mm.
atomic structure. And then last
Mm.
lesson we have actually gone through the theory on ions, isotopes. All right. So today we're going to go into more examples on this. Okay. By the way, Jane, do you have any idea what will you be covering in terms of science besides the chemistry part? Do you know what are the details that you'll be covering when school opens? Or not at all?
Don't think so. Leh.
Mm-mm. Okay, no worry. I will, just go on with this chemistry part first. Anyway, these are the fundamentals that you need to know for chemistry. If let's say when school opens, if there are any changes or if there are new things that we have not covered during the holiday, just let me know. All right. Okay, so let's take a look at this worksheet. Okay, let me open up the file first. You don't have the worksheet with you, right?
I do actually.
Sorry. What did you
I
say?
have the worksheet.
Oh, yeah, the worksheets lah. Okay,
I
okay.
think so. Is it the one that we were still working on the first worksheet?
All right, correct. It's the first one.
Oh, okay, there I have it.
You should also be getting another set soon because after we have gone through this topic, the next one will be revision questions. All right, and after the atomic structure, we're going to go into chemical bonding. In fact, we have also discussed about chemical bonding while we are doing this atomic structure because they are linked. So when we go into the topic on chemical bonding, I'm sure you'll be able to have a clearer picture as well. Okay, so let me show you this worksheet. Right, so this is the one, and we had done up all the MCQ questions. Right, we have done up all the MCQ questions and a few of the structured questions. So today we should be able to finish up this set of papers. Let me take a look at which are the structured questions that we have done. Okay, so do you still remember the concept on ions and how to read the the neutrons, protons, and the electrons from the periodic table?
I think so.
Okay, so we will do a recap when we do the structured questions, right? But do make sure that you remember them because when we move on to the next chapter, you need to use the same theory to work on the chemical bonding as well. Okay, so actually we are done with all the MCQ. We're going to move on to the remaining structured questions. So for the structured questions, we are done with question 1, right? Am I right, Jane?
Wait, let me check. The structure question.
Oh, yes, that's right.
Structure question. No, like number 1 is not complete.
Oh, number 1 is not completed yet, is it?
No.
Then what about 2 and 3?
We did 3, did not do 2.
Okay, because that is on isotopes. All right, then we have also done 5, right?
5,
5,
5, no.
5 not yet. Okay, and okay, so if that's the case, what about 6? 6, do you do 6?
Number 6?
Not yet, right?
I don't think so.
Oh, no, not, in my records, I've not done 6. I just want to double check.
Yeah, I have not done 6.
Yeah, and so if that's the case, then let's take a look at question 1. Since we have not finished the blanks, do you have a periodic table?
No, I don't.
Okay, okay. What about this? You have the hard copy of this, right? Are you at home now to get your periodic table, or you're not convenient to have a copy of periodic table?
I can Google for a periodic table, but I cannot like go and get one.
Oh, okay, well, then you Google the periodic table. I mean, the worksheets that you had is actually a hard copy, right? You should print it out, right? You printed out the worksheets, isn't it?
Yeah, I printed out the worksheet.
Okay. So if that's the case, maybe I will flash the periodic table on the screen, and then you fill in the blanks, right? So let me get a periodic table first, huh? Okay. Sharing this periodic table on the screen, could you see it?
Yeah.
Hannah? Okay. So you shall use this periodic table to derive the answer for question 1. Oops, this is too big. Okay, probably 75% is better. Okay, you shall use this periodic table to answer the question 1, and then we will go through the questions. All right, so maybe I will go through with you one example first to help you to do a recap. So if you have to look at this question 1, it says sodium has a nuclear number. Now another name for nuclear number is the mass number. Another name is called the mass number, remember? So mass number is often the bigger number that is written on the periodic table in each of the elements, right? Just like in this case, when we look at the sodium, okay, where's sodium in the periodic table? Sodium is this. It's a group 1. See this group 1? Right, this is called a group 1, 2, 3, 4, 5. All these Roman letters are the group number. It belongs to the group which these elements can be found. And what's so special about the group, right, is that they represent the electrons on the outermost shell. For example, lithium has how many electrons? 3 electrons. Now the smaller number, you can see this key here, right? The smaller number is known as the proton number, which is the number of protons or the number of electrons. Okay, whereas the bigger number, as I mentioned earlier, this is the mass number, the relative atomic mass, which represents the number of protons and neutrons. You got it? Okay. All right. So, okay. So if you were to find the difference between these two numbers, it will give you the number of neutrons. So like lithium, it has 7 minus 3, which is 4 neutrons, but it has 3 protons and 3 electrons. The number of protons and electrons are the same. Okay, the number of protons and electrons are the same. All right. So therefore, when you subtract them together, it will give you the number of neutrons. Now next, remember during the lesson, we have also gone through how to write the electronic configuration for lithium. That means the electronic arrangement. So since there are 3 electrons, we write it as 2, 1. Right, 2, 1. Does it ring a bell? We've done something like this, right?
Yeah.
Yeah, okay, so that is 2, 1. And what about sodium? Sodium, how many electrons are there for sodium, Jane?
How many what?
Electrons.
11.
Yes, very good, 11. Remember, the smaller number represents the number of proton and or the number of electrons. So 11, how do I write the arrangement? So 2, 8, 1. Right? So the innermost shell will always contain 2 electrons, followed by the second shell will be 8, right? And then the third shell will be the remaining ones, right? So what about potassium? It has 19 electrons, right? So Jane, potassium has 19 electrons, but how many neutrons does potassium have? Yeah, how many neutrons?
What? Neutrons?
Neutrons. Neutrons
39.
then have neutrons.
39.
No. The 39 is actually protons plus neutrons. Remember, it's protons plus neutrons.
Oh, 20.
Correct, 20. So you must subtract, you take 39 minus 19 to give you the number of neutrons. All right, the letter N neutrons. And then P is the protons. Now the number of protons here is 19. Number of electrons is also 19. All right, so if you were to write out the configuration, it gets you to 2, comma, 8. That makes 10, and then another 8 to fill up the third shell, and the remaining electron is 1. Okay, the remaining electrons will be 1. So can you see that a common thing between these elements in group 1, right? Their outermost shell will always have 1 electron. You see their configuration, right? Ends off with number 1. You get it? All right, so this means that this element has actually 1 electron on the outermost shell. It has 1 electron on the outermost shell, and hence we place them in the group 1. Understand? All right, so the significance of these group numbers represents the, okay, let's write it down, the number of the valence electrons. Okay, what I mean by valence electrons? That means they are the electrons on the outermost shell. Okay, they are the electrons on the outermost shell. Any questions? You got it? Okay, all right, so let me show you another few more examples. If you look at aluminium and boron, now why are they put in group 3? That's because boron, which has 5 electrons, right? You can actually arrange the configuration like this: 2, 3. Can you see the last digit is 3? So indicating that it has 3 electrons on the outer shell. That's why it's placed in group 3. Look at aluminium, it has 13 electrons, so 2, 8, and a 3 here. Right, so 3 again, because these are all the outermost shell. If you were to draw the structure, the atomic structure, let's see if I draw boron. Okay, then the innermost shell will have 2 crosses. And the outermost shell has 3. Like this. Got it? So that's how we arrange the electrons, and draw the atomic structure when we need to present the electronic arrangement on this kind of picture. Any questions so far? Okay. Can, right, Jane? Any questions, Jane? Got it?
Yeah.
Hannah, okay, good. So I'm going to leave this on the screen. On the screen, and then we will try and fill out the blanks for question 1. Right, since now you know that sodium has the 11 electrons, right? And then proton number is also 11. And what about the number of neutrons? That is to take 23 minus 11. Okay, Hannah? All right, so 5 minutes to fill in the blanks for question 1 by referring to this periodic table that's shown on the screen. Okay? Is that okay, Jane?
Yeah.
Okay, we put it in. All right, before I go through 5 minutes. Do you need any help, Jane? Jane?
No, it's okay.
Probably another few more minutes. Oh, Jane, sorry, forgotten to tell you about it. Now, can we end the lesson like 15 minutes earlier because I have to go back to the office to run an errand today.
Okay.
I'll make up 15 minutes for you on the next session. Is it okay?
Okay, okay.
Okay, can. So, let me inform, should I inform your dad or your mom now? Because your mom is not back yet.
Can you just inform my mom lah?
Okay, okay, thanks. So we end at around 11:15, right?
Yeah.
Okay, Okay, ready? We're going to run through the questions now. All right, so for question 1, Jane, are there? Yeah, I'm going to go through the question now.
Yeah, can.
Okay, so for question 1, proton number of the sodium will be 11. All right, electrons is also 11. The number of protons is also 11. All right, so you can see that the number of neutrons is 12 is because you take 23 minus 11, it gets you to 12. All right, so what about the oxygen? Oxygen, what's the nuclear number, mass number? Jane, what is the mass number for oxygen? Sorry, Jane, could you find oxygen on the periodic table?
Give me a second.
Sure, sure. You want me to flash back the periodic table? Yeah, so this is oxygen, Jane. Did you see oxygen?
Yeah,
What is the mass number? That means the
16.
number. That's right. Then number of electrons is
8.
8. Okay, and then the number of protons is also 8.
8.
Yeah, so and what about the number of neutrons?
Also 8.
Also 8. All right, so just find a difference. Okay, so let's go back to the question. Yeah, so what about xenon? For xenon, the number of electrons will be
Number of electrons would be
the number of electrons is the same as the proton number.
yeah,
Okay, so it's a smaller number, so that'd be 54. Then number of protons,
also 54.
that's right, so also 54. Okay, and the number of neutrons, you must take the difference, 131 minus 54. All right, so 131 minus 54, you will get you
77.
Yeah, thanks. Okay, so this is calculator 77. Okay, then what about barium? So barium, we refer to the periodic table. Barium, Ba. Barium is in group 2. I see, I see. All right, so this is barium, Ba. The nucleon number is 137. The proton number is 56. Right, 137 and the other one is 56. Okay, so putting down the information. So this will be 137 and this is 56. Right? Which tallies to the number of electrons. And what about number of protons? It will also be 56, right?
Yeah.
Yeah. All right, so what about nickel? To refer to the periodic table, what is the nuclear number for nickel? In fact, you can just sum up the number of protons and neutrons, right?
59.
Yes, 9. Okay, so this is 59. And the number of protons will be
28.
28, that's right. Okay, and the number of electrons will be
28.
That's right. Okay, good. So that's a quick practice on identifying the number of protons, neutrons, and electrons. All right. Okay, so let me clear this drawings. Okay, now for question 2, you wouldn't be able to do it at this point of time except for part A. So let me just go through question to review on the spot. All right, so how many neutrons are there in this silicon nucleus? So you're going to subtract. All right, take 28 minus 14. This will get you to 14 neutrons. All right, 14 neutrons. Okay. All right, this one we can't do. You can skip that. Oh, yeah, I think we can. Hold on, let me just check. Yeah, we can do this. All right, just put in the number of electrons according to the electronic configurations. Remember, I told you the inner shell is actually 2. The next shell will be 8. Right, and then the last shell, how many electrons do you think there are? In the silicon, there are 14 electrons, right? 14 electrons. So now you're supposed to arrange the electrons on the shell, or on the orbital, the electron shells. And we always say that we're going to start with 2 electrons on the outermost, on the innermost shell. So it's 2, then followed by 8, and what's the remaining one, Jane?
Sorry, repeat.
Electrons,
Uh,
2, 8, and then this is?
4.
Yes, very good. 4. Okay, okay, you pick up pretty fast. What am I doing? Okay. All right, so that's the answer for 2B. You can't do 2C, haven't learned that yet. All right, so let's do out this question 3. How many neutrons? Question 3 done already, huh? Is it? We've done question 3, yeah? Okay, so let's keep
3 is done, yeah.
Okay, so if that's the case, I think question 4 is quite interesting. Could you see all those small tiny numbers in the nucleus? You can, right? Yeah, those represents the number of protons, neutrons, and the electrons. All right, so let me enlarge a bit. Let's do this small. This one. All right, so I want to use these diagrams to fill in the blanks here. Like for example, in the atom A, we have 7 protons, 7 neutrons. So 7 proton means that the proton number is 7. 7 neutrons and 7 protons makes up the total number of 14, which is the nucleon number. All right, and then whether is it matter or non-matter, I'm going to name the element. All right, so do you think this is matter or non-matter? You have to refer to the periodic table. All right, you can see that there are 1, 2, 3, 4, 5 electrons on the outer shell. So for 5 electrons on the outer shell, you have to refer to the periodic table, and that tallies to the nitrogen. This is nitrogen. Right, so nitrogen is actually a non-matter. Okay, so we say this is a non-matter. Right, and the name of element is nitrogen. So you just have to type it out. I think I'm going to type out it's neater to type out, please. Okay, before I type it in, show you the periodic table. So if you look at the periodic table, see this is 14, right? 14 nucleon number, 7 plus 7. So that's how we identify this as nitrogen. All right, so nitrogen is a non-matter. In the basic periodic table, they have a divider here to divide the matter and non-matter. So it's like a staircase kind of division. Like this. Okay, so actually there are a lot of examples or a lot of elements that are matters, but only a few examples on the non-matters. So that's how you fit it in. Okay, so going back to the question. So just now we said that there are 7, all right, proton. The nucleon number is 14. This is a non-matter. Non-matter, and what about the name of the element is nitrogen. Yeah, that's how you should fill in the blanks. Right? Okay. Okay, so another 5 minutes for you to fill in the blanks for these questions. Is it okay, Jane?
Yeah.
Yeah, okay. I think the first two columns shouldn't be a problem for you. It's quite easy. You just have to sum up the numbers to find the nuclear number and then you just copy down the proton number. The last two columns, you're going to refer to the periodic table and identify what elements are they referring to. Right, so give it a try first. Jane, how is it? Yeah, just let me know when you're done.
Oh, okay.
Okay. All right. So no worry, I'll just guide you through on these questions first.
Oh, okay.
So let's fill in the blanks. Proton number for the atom B. What is the proton number for atom B? Just 6. You see the
Oh,
small,
yeah.
right? Yeah. Okay. And then what about the neutron number? So that will be 6 plus 6 because 6 protons and 6 neutrons.
12.
That's 12. The neutron number is the total number of protons and the neutrons.
Mm.
That's 12. So if you refer to the periodic table, this refers to the element which is oxygen. The element which is oxygen, so that is a non-matter. Got it? Okay, yeah, so non-matter. No, it's not. Hold on, let me just double check. 6 protons. 6 protons should be carbon, not the oxygen. Oxygen is actually 8 protons.
Oh,
Yeah. You have a table, right? You can actually refer to it. So this one is 6 and this is 12. And then this non-matter, let's use NN to represent non-matter. And then the element is oxygen. It's sorry, carbon. right? Carbon. Can you locate carbon in the periodic table?
Yeah.
Yes, right. Okay, so it has 6 protons and then 6 neutrons. All right, so next element, next atom, C. So the proton number is 11. Nucleon number is 23. Right, and then the elements, which elements is this? Refer to the periodic table and locate where is 11, the number 11. 11 proton. Now, what is the element?
Wait, I have no idea where it is. Oh no, found it. Sodium.
Yeah, very good. Sodium. Okay. So that's the sodium. And is this a metal or non-metal?
No metal.
Oh no, sodium is actually a metal. If you see,
Oh,
yeah, sodium is on the group 1, correct?
yeah.
So group 1, group 2, and even group 3 are the metals. As I mentioned, there are more metal elements than the non-metal elements. The non-metal elements are on the extreme right. Just like I showed
Oh,
at the staircase separation, right? Let me show you something. You see this? This is a periodic table, all right? And then the non-metals are only those that are green and the blue. So it's only this area, this green part here and the last group. All these are metals. You can see the metals have a lot more examples. Got it?
yeah.
Okay, so that's how you read the periodic table. Okay, back to this. All right. So we're going to fill in the blanks for the rest. And yes, so C is the sodium. And what about B? B proton number is 29. And a nucleon number. Now, nucleon number, you just have to sum it up. So it gets you to 64. Right, 64. Okay, and if you see the periodic table, where is 29? Which element has atomic number of 29?
Copper.
Copper, right? Yes. So is copper a metal or non-metal?
No metal.
Ah, no lah.
Oh wait, it's a metal.
Yes, metal. Okay. Yeah, so that's metal. And the last one, 8 protons, 8 neutrons. What is that? So you locate the digit 8.
Oxygen.
Oxygen. So for oxygen, there are, then the proton number will be 8, right? Let's scroll up. Yeah, so for oxygen, the proton number will be 8. Okay, so that's 8. And then the neutron number will be 16, right? 8 plus 8 is 16. All right, so is it a metal or non-metal for oxygen? Is oxygen metal or non-metal? Yeah, Jane, is oxygen a metal or non-metal?
Non-metal.
So it's non-metal. All right, any questions? Yeah, so that's how you do this kind of questions. Huh? Okay, let's take a look at question 5. Okay, now for question 5, you should be able to do 5A. Question 5A. All right. And also 5B, writing down the formula for the ions. Okay, so give it a try first before I go through. Right, let me erase this. Okay, you can try 5A and 5B. I just have to keep trying the same questions again and again so that you will be able to remember how to, how to read the informations in the periodic table, right? Okay, so you give it a try first. Jane, I need to go to the toilet for a while. Give me a minute, okay? I'll be back very quickly. Okay, Jane, shall we go through the questions now? Right, so if you refer to the periodic table, you can see that the number of protons for gallium is 31 because the 31 is a smaller number. The smaller number will always represent the number of protons. Right, so this is 31. Same for this gallium isotope is also 31. Now, actually, we said that for isotopes, the only difference is that they have different number of neutrons. Right, they have different number of neutrons. So can you see that the mass numbers are different? This is 69 and this is 71. Right? Okay, so therefore, if you find the difference between 69 and 31, this will get you to 38. Right, so this has 38 neutrons. Okay, but then for this, it has 40 neutrons because both are isotopes. Right, isotopes are atoms of the same element with different number of neutrons, but same number of protons. So what about electrons? Jane, how many electrons are there for this gallium-69?
31.
So it's also the same, 31. Number of electrons and number of protons are the same. So the same goes for gallium-71. It also has 31 electrons. Okay, then for part B, we're going to write down the formula for an ion of gallium. So we said that ions are referring to the particle when the atoms has either gained or lose electrons. So like gallium, if you refer to the periodic table, it is in group 3. Right, group 3. So which means that it has 3 electrons on the outer shell. Okay, so 3 electrons on the outer shell. Right, so it has 3 electrons on the outer shell, then it should be able to lose 3 electrons. So when it has lost 3 electrons, the formula should therefore be gallium Ga3+. Remember, loss of electrons will always end up a positive charge, right? Now, whereas if the elements were to gain electrons, it will end up having the negative charge. Yeah, so therefore the answer for part B is Ga3+. Understand this concept?
Yeah.
Anna? Okay, good. So you got it down. You jot it down.
Yeah, I wrote already.
Okay. Clear now. Okay, and next question is question 6. Right, question 6. So which particles in these ions have a positive charge? So this ion of the element X that contains 12 protons, 12 neutrons, but only 10 electrons. So can you now see that the protons and electrons does not tally anymore? So that means it has actually lost 2 electrons. Right, so loss of 2 electrons will end up with a positive charge. Now, what is the charge? 2+. Right, because it lost 2 electrons. Agree with this? Okay, All right, then what about which particles in these ions have no charge? So it's always the neutrons. Okay, remember we said that neutrons is the subatomic particles that are neutral. Oh, actually, this one, the particles that they are referring to is referring to the proton because protons have positive charge. Because it asks for the particles in these ions. So that's protons. Right, at first I thought that they're asking for the charge of the ions itself, but it's actually referring to the protons. And this is the neutrons. So what about the mass number of the ion? What's the mass number of this ion, Jane? The mass number, just
22. Oh, wait.
12 protons, 12 neutrons, right?
Mm.
So that gets you to 24. You see that?
Yeah.
24 as the mass number. Okay, then what about part C? Periodic table to identify the elements. I'm going to use the periodic table. So if you refer to the periodic table, 12 protons is referring to magnesium. right? So that's a magnesium. You know what's do you know which group does magnesium belongs to?
Not off the top of my head.
Okay, you refer to the periodic table. Can you find magnesium?
Second line.
The second column, is it?
Yeah.
Okay, so for the second column, you can see magnesium. That is because it is in group 2. Got it? It's in group 2.
Mm.
So that's because magnesium has 12 electrons. All right, when we write the configuration of magnesium is 2, 8, 2. Right, 2, 8, 2. Understand? So can you see this letter, this number 2 refers to the electrons on outermost shell. So therefore, it is in group 2. Right, and because it is in group 2, it will lose these 2 electrons in order to form an ion. So the ion will have a stable configuration. Got it? Okay, so when it has lost 2 electrons, it will turn into the magnesium ion, which has a chemical symbol of Mg2+. So I'm going to include the charge and write the chemical symbol for this. Get it? Okay, good. So remember, matters will always lose electrons to form the positive ions. But on the other hand, non-matters will gain electrons to form the negative ions, as what we have gone through in the concepts on ions itself. So once you have understood the concept of ions, the next lesson we're going to go into chemical bonding. Right, we're going to look at how the positive and negative ions will interact to form the compounds. Got it? And Jane, any questions? Yeah, so Jane, next lesson, I will extend I'll make up the 15 minutes for you for the next science lesson. All right, if there's no questions, we will still have a math on the Tuesday and then science on the Wednesday for next lesson. I'll let you know again. Is it okay? Anna, okay, so you take care. I'll see you then.
Okay, bye.
Bye-bye.